Okay, so Tom the cat. I can't draw Tom the cat or Jerry the mouse. So here's a box. Here's a box. I have no art skills at all. Yeah. Well, here we'll make it. Yeah. Well, let's see who's going. Jerry steps out of the way. So Tom the cat. So here's some ears on him. There's some ears, and here's a little tail. Yeah. I don't have any art skills. So Tom the cat slides off this table with a velocity of 5 meters per second, and we're given the height of the table is 1.5 meters. So then Tom flies through the air and lands a distance x from the base of the table. All right, so we're being asked to solve for two things. So one, where will Tom strike the floor? That's x. We're solving for x. And then two, what velocity components will he have just before he hits? All right, so let's talk about how you set this up. The key thing with projectile motion is that you're separating x direction from y direction. So for example, this 5 meters per second here, is that an x velocity or a y velocity? That's an x velocity, right? That's perfectly in the x. Now, what is Tom's y velocity as he leaves the edge of the table? 0. He doesn't have one. So Vy initial is 0. Okay, so what else do we know? Well, as Tom flies through the air, so here he is right here, what do we know about his x velocity? It's going to stay the same. And that assumes no air resistance. If we did have air resistance, his x velocity would get smaller. But in physics problems, we always assume no air resistance. Now, what happened to his y velocity? His y velocity went from 0 to something larger. Okay, the y velocity is increasing. So, how do we put this down? Well, constant x velocity is the same as what? Saying x acceleration. Acceleration in the x is what? 0. Constant velocity is 0 acceleration. And then what about our y acceleration? It's gravity, which is negative 9.8. Gravity acts in the y. Gravity cannot touch the x. Gravity cannot get to the x direction at all. All right, now this 1.5 right here, the height of the table, that's our vertical displacement. Okay, and it's going to be negative. Now, why is that negative? Well, our sign convention goes like this. Up is plus, down is minus. Okay, so did Tom the cat go up 1.5 meters or down 1.5 meters? Down, so that's negative. Okay, so now we're ready to solve for x. Can we solve for x directly with one calculation? The first thing we have to do is find time, which is a very common thing. You know, in a lot of these problems you're going to have to first find the time. And by the way, time in the x direction is the same as time in the y direction. Okay, so find time. Now, when you do these problems, you got to make a decision. Are you going to solve for whatever it is you're looking for? Are you going to solve for it using the x direction or the y direction for every single calculation? Because you never, ever, ever use x and y in the same equation. So for finding time, are we going to use x or y here? The y. And that's not to say that it's always the y. Sometimes you'll use the x. All right, so finding time, we're going to use the y here. We're using the y direction. So I'm going to write out the first kinematic. Y equals 1/2 gt squared plus vy initial t. What is the initial y velocity? 0. So now you take that and solve for t. That's going to be 2y over g. And now we plug numbers in. 2 times negative 1.5 over negative 9.8. So the negatives cancel. And we get a time in the air of 0.553 seconds. So now that we know the time in the air, we can solve for x. So now let's find x. Where will Tom the cat hit the ground? So the only x equation, the 4 motion equations reduce to one equation, which is v times t. Horizontal displacement equals v times t. And where does that equate? Basically, what is this equation? This equation here is basically what? Velocity is displacement over time. That's all it is. Okay, so x, so what's our x velocity? 5. And then we now know the time in the air, which is 0.553. So we know exactly where Tom the cat is going to hit the ground. Rounding this off, we'll just round it to 2.8. Okay, 2.8 meters. All right. Is everybody good on that? Now, the next part. The velocity components he'll have just before he hits. So let's shrink this down. Stick that up there. Okay, so what do they mean by the velocity components right before he hits? Well, when Tom hits the ground, he's going to have an x velocity, right? Is he also going to have a y velocity? Yes. Now this problem is asking for the components, right? See that word there? The components, which they mean vx and vy. Well, what's vx? 5, right? That's one of the components. What's the other component? Vy, which we have to solve for. So how do we get Vy? Well, I would go like this. Vy final equals Vy initial plus GT. That's the third kinematic. What's Vy initial? 0. So Vy final is going to be G times T. So negative 9.8 times 0.553. So this comes out as 5.4. So guys, hold on, just hold 1 second. These are the components. Now hey, on the quiz, what if I ask you for the total velocity as he hits the ground? The total velocity would be what? The hypotenuse. Well, you use Pythagorean theorem.